Okay, ladies and gentlemen, welcome to solving systems of equations by substitution. So let's start with a nice easy one that we actually kind of did in class today. So in case you missed it, so I have two equations. I have equation A, and let's say this is negative x plus y equals 1. And then we have equation B, 2x plus y equals negative 2. So what I want to try and find, my first objective is which one has a single variable. And just as a little side note, single variables would be things like a, x, y, m, n, pretty much anything of the alphabet as long as there isn't a number in front of it. The invisible one, that's okay, but we don't want a 2, 3, 4, or any of those negatives. So let's just single ugh, variable. Sorry about the handwriting. So let me just go through and highlight. So this could be considered a single variable, this, and this. So for the ease of this presentation, let's start with A. I have negative x plus y equals 1. This one is what I'm going to solve for though. Just because it's nice and positive, I don't really have to worry about it. So minus 1, same thing, or I'm sorry, the inverse is going to be plus x. These cancel. Y equals x plus 1. So this part is the really important part. The fact that we used equation A and we found out that y is x plus 1. We can substitute things in there. Think about substitution like sometimes you have one of your teachers, sometimes you have a different teacher. They are usually substituting in. Or, in my case, I'm trying to cut down on drinking all the pop, so instead I drink water with flavoring. It's not nearly as good, but it's a substitute. So, we're going to take this, and since we've already used equation A, we have to use equation B. So we have 2x plus x plus 1 equals negative 2. Now this part comes because in equation A, we found that y is the same thing as x plus 1. So since they're the same thing, I can use them interchangeably. So then when I have this, let me try and figure out where my mouse went. We have 2x plus 1 equals negative 2. Combine like terms. I have 2 x's, I add 1, we have 3 x's plus 1 equals negative 2. We're going to solve for x. So subtract, and I just wrote an x instead of saying 1. I'm so sorry. We're going to subtract 1 from both sides. You guys already knew this. You're ahead of me. 3x, and then negative 2 minus 1, or negative 2 plus a negative 1 is a negative 3. Now we divide by 3 on both sides. X equals negative 1. So this part is really important. The arrows may look confusing, and I apologize, because I'm going to go back up where we said, hey, this is y. And instead of my x value now, I'm going to replace that. So y equals x plus 1. But remember, we're changing that, so it's going to be y equals negative 1 plus 1, and y equals 0. There's my solution. X is negative 1 and y equals 0. Okay? Hopefully this isn't too bad, but let me go over one that I found not so nice. Okay, so this is actually, if you're paying attention, number 12 from your homework. And we have 5c plus 3d equals 11, and I have 5c minus d equals 5. Equation A, equation B. I want you to remember that C and D is just another form of X and Y. Kind of like saying, hey, I live over here. Oh, well, that's the same thing as me, I live on this street. C and D, A, B, C, they're all variables. They all represent a mystery number. So let me highlight which ones have singles, and it only looks like this one. So I'm going to start with that one. Equation B. So 5c minus d equals 5. And I'm going to solve for d, so I have to subtract 5c from both sides. Negative d equals negative 5c plus 5. Remember, we can't combine our 5s and our c's because it's going to create a whole mishmash. C's can't be with non-C's, D's can't be with non-D. It's all of that stuff. And there's the invisible 1 in front of this, so we're going to divide by negative 1. And we need to do it to all the parts. D equals 5c plus a negative 5. Just going to go through and hopefully highlight this for us. It's not going to turn out all funny. Okay. So this is our D. And we've already used equation B, so now we have to use equation A. A says that 5c plus 3d equals 11. Okay, so sorry about that. So we now have our D value. We have our A equation. Now remember, we're just going to take that equation and we're going to plug it in for D. So this one's a little bit harder. So we have 5c plus 3, and I'm going to put parentheses around everything I'm putting in there. So it's 5c plus negative 5 equals 11. So we don't need the d anymore because we've taken the place of it. So we have 5c plus 15c plus a negative 15 equals 11. We're going to combine our like terms. 20c plus negative 15 equals 11. We need to add 15 to both sides. And this is why I said this one's not going to be so pretty. 26. Divide by 20 to get c by itself. Let me move this down. And so then c equals 26 over 20, which is really 13 over 10. I could also change it, but since we're going to put it into D, I like it in this form. Otherwise, it's 1 and 3 over 10. So if we were to graph it, the point would be 1, 3 over 10. But now, I need to take this, and I'm plugging it in for my C. Oh, I'm so sorry. That just was really, really bad. Let's see if I can erase that one. Oh, no. Too much eraser. Okay. Well, we knew it was 5C. So this is D equals 5 times 13 over 10 plus negative 5. So if you remember how to cross cancel, so we can take this out and because we're dividing it by 5, and then we can do that here too. So we get 13 over 2 plus negative 5. D equals 13 over 2 plus negative 10 over 2, because we need that common denominator. So D is really 3 over 2, or 1 and 1/2. So if we were to graph these, one of the reasons we use this is because it's really, really difficult to find that point where they're going to cross at 1.5 and 1 3/10. So this is one of the reasons we do this. Please, please, if you have questions, let me know. We're just going to keep working on these and I will keep posting videos. I'll talk to you guys later. Have a good weekend.